yeah, first I want to say that there's a pretty awesome functional programming conference. It's tutorials from Skills Matter. They've done tons of stuff in London. You can check them out online. And they're coming in. Don Syme will be there. Tomas will be there. Phil Trelford, Kevin Hazard, a whole lot of, Chris Marinos, a lot of people you might recognize from the internet and F-sharp community. It's very exciting. And there's 2 tracks. It's going to be beginner and advanced. I recommend going soon because reserving a ticket if you want, because ticket prices are going to go up pretty dramatically in the near future. So please check it out. And I think you won't be disappointed if you come, because it's going to be really awesome. I'm so excited about it. All right. But on to the meat, right? So it's not something I undertook lightly, making a language and using it at work, because you hear this all the time. Don't do anything if someone else has already done for you, right? Like, it's not a smart thing to put all this maintenance on yourself and worry if you can avoid it. But I felt like I had no choice. So mostly what I wanted is, it's a very standard sort of thing that you can sort of expect most people want, which is why I was really surprised that I couldn't find anything that really did it. But just like at the top here, where you just imagine like any kind of list view where you have records and you have all the contents. You just want to do queries inside of your app. And there's no real language that does that well, because the problem is they're all too structured. They're designed like any language that is any given language is designed for building whole programs, right? And it's too much in that direction. So you put lots of parentheses and casts and types and everything else. And this is not adequate for a normal like domain expert to sit down and query the data. It requires too much thought about what it is, not what you want to do. Now, I think that I'm not a big proponent of dynamic languages in general, because I feel like when you're building programs, they don't save you from things going badly. But if all you're doing is typing something in, and you're going to execute it right now, there's no time in the future where this is going to fail drastically. So there's no real benefit to static typing in this particular case. So I just wanted something that seamlessly integrated, did my type conversions for me or anybody else, and was easy enough and predicate-y enough for someone to use. And I think I've achieved that at this point, which is very exciting for me. So I tried Iron Python, Iron Ruby, Iron JavaScript, and they're all great. And I found Dynamic Link after a while, which was only available in, I think I got a free blog post, and it was never, it's never like an official thing. It was just some zip file on his blog. But I tried it, and Dynamic Link, it was to show off before I think C# 3.5 came out, some of the new like expression features. But I was like, wow, this is almost exactly what I want, except you still had to do your casting manually.
That was a class that took a string expression and converted it into a real expression?
Yes. And so that's effectively what I built, is I rebuilt a Dynamic Link, but with some additional features and with dynamic typing. So it's pretty cool. And it doesn't do everything that does. It's not a complete overlap, but it's like what I was aiming for the user experience to be like, because I thought it was just really nice and concise and anyone could pick it up. But at first I did try. I downloaded that source, and since it's open source, I tried to hack on Dynamic Link for like 3 days to try to make it do the type conversions itself, and I just couldn't make it work in all cases. And the code base wasn't very friendly. I can see why Microsoft didn't go further with it, mostly because it was sort of a proof of concept. It would need a lot of work to be something mature. And I just found that because it was in C#, it would actually take probably less time to mature my own thing from scratch in F# than move forward in C#. So initially, I've never really written a language before. Just played around, read a lot of stuff, college and whatever else. But so I'm not an expert on this. So I went like in a really staged approach. At first, I was just like, I'm going to cut this in as many pieces as I can to try to make this something that I can attain, as opposed to try to like clobber it all at once and then just lose my mind and not be able to handle it. But each of these steps is pretty easy. You just parse it into tokens. You convert it into like a discriminated union in F#, which is fantastic. It's like pretty much designed for representing languages. This group, like the ML family tree, it comes from for writing compilers, so it's perfect. And then I just optimized it via reduction. Then I got into sort of the problems, like converting. I had this idea that I could make it really fast if I could take the discriminated union structure and then turn those into lambdas and then compose all those lambdas together. Maybe that was just reaching a little bit too far. But the benefit of that is pass back the result function, right? And it's easy to build up with extra stuff to just tack it on. Function composition is really sweet that way. But in the end, I couldn't make it work. First of all, it required a ton of mutation. Because once everything's wrapped up in these functions, you can't see the guts anymore. So you have to do like hidden machinery to do the caching inside the function. And also the automatic conversions, you had to stuff tons of stuff that wasn't always necessary into the functions. So the functions got bloated and slow. It was bad. You need to figure out a ton of stuff at runtime, and the code is just a nightmare, and I ended up trashing most of that model in the end. The first working implementation, I actually cut it down a little bit. And this is sort of the theme that goes through my experience with this is less is more. Like don't try to do too much. Just try to attain it. Do what's attainable. So, the token parsing is easy. Just cut things into pieces based on some simple rules about, like a parentheses always gets cut. And you have your list of things that always are terminating after, and a list of things that require a white space and whatever else, and just tokenize it up. Then you just convert that into discriminated union. They're pretty much pattern matching, just like one-to-one almost. And then I have a separate function that nested things, because you have like paren, blah, 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 paren, and you have to say like that's a sub-expression, nest that up. And then the final step would be to reduce that based on initial knowledge. So like you have because what you give this is a strongly typed function from something to something, or multiple things to thing. You know ahead of time what it's going to be given. So you can optimize that, and initially you can say, okay, I already know this, so we don't have to worry. I don't have to think about doing any kind of lookups or anything. I can just stuff in where I know this stuff will be, which is good. And then I also figured out that I didn't need to do this function-to-function thing. I just wrote my reducer, my optimizer, in a way that combines things until there's nothing left. So all you do is you run the same thing that executes it to optimize it. So you just do it with partial information first, and a little bit of tweaking to the rules to say don't fail in these cases when everything is complete. And then when you actually have complete information, you run it again, and you just reduce it down to the final result. I'll go into this more later, how this all works. Just trying to give sort of an overview. Now, there was definitely some problems with this. This is initial implementation about 6 months ago. And the biggest problem I found definitely was that there were multiple places for a new feature, like a lot of them, right? Because you have the parser, you have to say what I should parse out separately, and you had to say, you had to turn that parse code into discriminated union code, which I just found broke a lot when I tried implementing features, especially when the new features had to be nested like the else. And the repetition was killing me too. It just like it got kind of bloaty, and so you were always tempted to try to hack things in wrong because of that extra work. And I ended up just throwing up my arms one day and be like, I'm going to rewrite this mostly because I've learned a lot of lessons, and these lessons say I should take an easier approach. So in the current implementation is really just a two-step implementation. So because you see each step, each time I'm doing less. But each step is doing more itself, but it's doing less overall. So I read about these parser sort of the idea that you don't necessarily need to tokenize and parse separately and then do an intermediate representation. You can just go straight from the text into the thing, into the tree. And so I tried it, and actually wasn't any more complicated, and it actually made my life a lot easier in the end. Then the reduced and on initial knowledge pretty much stayed the same from the previous version. I just had to tweak things a little bit because now, because of list reversals and such. So yeah, just reduce. It's pretty simple now. The code base is quite small. In fact, the reflection is most of my code, like interop with the rest of .NET. Also, this uses no DLR. It could probably be ported to something like standard ML really simply, which is something that I wanted just in case. Like we're going in the future, we have all these, we use this software now to write some dynamic machine learning rules in our production system. And so it needs to be portable to the future, and that was one of those things. Also, I didn't want to worry about Microsoft dropping certain tech or whatever. I just wanted the whole thing to be standalone, and so on the rocks of that. So the reduction phase is the most interesting phase, I think. This is where you have essentially two lists, a left-hand side and a right-hand side. And then you combine down the tokens to smaller sets of tokens. I started off with just the left head and the right head, but to be able to do infix invocation with correct order of operations, I need to look at 3. It just turns out that way. I thought for like weeks about that problem. I was like, how do I do this without looking at 3? Just came to the conclusion it's impossible. But so when you have just one thing, usually that thing is either going to be an unknown, which turns into a variable, or so binding a value. You might be returning. So I have this mechanism because I kept on forgetting. There kept on being bugs in my code where I would return something from .NET space, but I have certain constraints that must hold within my subset. Like I only allow 64-bit integers and doubles. Like for those types, anything that can fit into those gets upcasted into there, just to make my life easy. We run this with like hundreds of thousands of records, and it doesn't really impact the performance at all. So I'm not too worried about it. And if it becomes an important thing later, it's pretty easy to hack in. It's all about certain assumptions in the code. But so like those things, when something gets returned, it's always wrapped with return. So I always know the next thing I do when I look, it'll be an RH as a return, wrapped in a value, and I'll say, oh, now I have to convert this to my space, and then it's turned into an object format, and then placed on the left. There's also other things that are only one token, and that would be like an entire sub-expression fits into one spot. That way, you can recurse on that. So like there would be like a if statement would be like in one spot in there, right? Because then you want to do special things in the if statement. Like you want to optimize it somewhat differently, and you have to worry about like if it's been correctly terminated or not. There's 3 expressions in it. You don't have to care about all the expressions if they don't get hit. So there's quite a few cases there that fit into that recursive nested on one token. And then there's also the, I didn't list it here, but there's one called unfinished or something like that. I can't remember off the top of my head. But it pretty much indicates that I looked at this and I didn't do anything to it. So you don't need to look at it again, move to the left after. It's mostly just to avoid infinite loops in the code, which was a problem early on. Then, so when you have 2 of them, though, this is pretty standard. You're like, it's a dot. This is like an invocation on something, and it's something else. So I combine those 2 to say, like, this is you would say like dot, and it would say unknown, right? So that's like, I'm invocating a member. That name, that unknown is the member name. So it might be a property, whatever else, depending on what comes after. And then it squishes it down. Then it'll look on the other side, it'll be like, oh, it's an object, and I have an invocate on a member thing, and it switches those down, it'll like invoke and get the result. Put it in the code there. So also there's like Lambda expressions support. Partial application needs to happen in this context where you're switching something onto a Lambda. There's a lot of things that need 2, right, in a pair, and then you that's the sort of canonical idea in this whole thing is you take the left and the right and you squish them, take the left and right and you squish them, and eventually you run out of stuff. And yeah, like I said before, the only time you need to look at all 3 is really for this infix invocation. I would love to, if someone's like a language designer, talk to them about this. Maybe there's a better way. But I found that you need to look at the precedence of the neighboring operator to be able to know. So it's unresolved, that's what I was saying. So yeah, unresolved stuff just gets moved to the left. Return gets tweaked into the correct type. If we don't have a match, we move to the left because maybe it's an unknown and we need to do, like one of the cases where that would happen is you're doing a global, like a static lookup to a static class member, right? So you have an unknown, a dot, and another unknown, or something like that, or a whole chain of those. And so yeah, if there's only one element left, then that is the result, right? So that's how you know you were right. And then if there's a certain case, right? If you're executing, it's the second return stage. There's a Boolean that determines this if I'm in the final stage. If that Boolean it says I'm in the final stage and I still have lots of stuff left when I get to the end of everything, then I know that something went wrong. No matter where I am, even if I'm in a sub-expression somewhere, and I get to the end of that sub-expression, and I wasn't able to figure out the contents of the sub-expression, it's game over. So that's how that works. And then if I'm just in the optimization phase, I don't really take too much care. There's a few corner cases where I identify things going wrong initially, but since running stuff for this happens immediately after sort of compiling it, it's not really necessary to put too much effort into the correctness at that time. So there's also this second idea that I came up with in order to sort of make my life easier on the parsing. And I'm sure someone else has done something similar to this, but I didn't read it anywhere. So I'd rather implement than read sometimes. Once I feel like I've experienced enough, I can't read everything, or else I'll just sit there in a chair and never do any work. So there's really two kinds of things that you do when you're parsing, right? There's a token, like a basic token, like greater than the new keyword. You don't need to know anything else about that besides that. But then you have something like a parentheses. You need to be able to lift everything up that's inside of that, especially when you're parsing on the fly. So it's really, you need more of a pattern language for that. Like something that says, like, this is what I'm going to expect to see in this case. And it's especially true with something that's sort of like F#, where there's lots of open-ended statements, right? Like you have an if-else, there's no curly braces. So you need something to bound that. And the bounding thing can be the parent structure. So you can say, like, I'm in parentheses, and I know I'm never going to end. Like I'm an if, then, else. And that else never has anything that says it's done. But as long as there's a parentheses around it, or the end of the entire function string is found, then I know that like the parent is terminating, and so I can terminate it. So pretty much I put the simple stuff in a place where it can't go wrong, and then the complex stuff I hammered on for a while until it was right. This is sort of what it looks like in the code. I'm sorry, it's not big enough. Everyone see that all right? I see some heads in the front, kind of stating yes, but. So this is like what the simple part looks like. It's not all of them, but like dot turns into invoke. Parentheses is just the unit type, which says, I use mostly for invocation. It's a unit, like you're passing the unit into something that doesn't take any arguments. It's sort of a same idea as F#, sort of. And then we add our new, null, blah, blah, blah. This is more interesting stuff. This is sort of a nested pattern DSL that I came up with. Like for instance, this is a tuple representation, and it's just an open expression that's separated by some number of commas, right? So that RCAP, what RCAP means is this can be repeated. R is since repeated, and it's captured. So it's like, and then it puts that into a structure. And then on the right-hand side of each of these is a func equals blah, 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 where you pass it a function. You put a function as part of the record type that says, execute this function with the result of whatever I parsed here. So I'll take the discriminated union components in the chunks that are separated by the things here and pass that to some function that turns it into the right kind of thing. So they can be fairly complicated, but in general, they're not. Usually it's like, this spot is not supposed to have anything in it, it's like an error. Or like, in the case of if, then, else, it's if, then something, then there's something else, and it's always in the same order. So you can just look at that. And if there's too many things, something went wrong, you can, I don't know, it's pretty safe. The other thing is you might think, well, how do I know which one I'm in the case where the pattern happens? And I'll get into that in a minute. Okay. So this is the nested pattern sort of parsing idea. And there's really, it'd probably be retrofitted to be a little bit more elegant, but these are really two ideas mushed together. I did the simple parsing first, and that was really easy. And then I did the complex language, and that was harder. And so there's two functions sort of for each one. And maybe they're not named perfectly, but you can always refactor that later if necessary. So when something eats that, it's what it looks for in the expression language. So like a new expression just looks for anything that starts with an S cap and an R cap in the set of all things. And it'll eat that and then say, this is what I'm in. Or more precisely, it says, I'm in one of these things based on what I know. And if there are multiple letters, it'll pick whatever one is longest. So it's pretty much based on constraints about what information is available. Then, in our refined open expression, it's pretty much the same thing as new expression, except because it's an open expression, we're saying, I'm already in some sub-expression. And then, oh crap, I'm really this other kind of sub-expression, right? Because I'm saying I found this token, and oh god, what do? So you turn that into the right kind. Here, we pretty much are dealing with the end of one of these, one of the simpler non-open expressions. So we're saying either an S cap, which is a single capture variable, which is the last one, right? So you say, I ate the last one, so I'm done. The R cap is saying, I ate this, and maybe I'm done, because there could be another one. And then there's, so the logic actually is the most complicated in this one, because there's this whole R cap case where you're not sure you're done. And then there's R cap and then an S cap, and you're looking for the S cap, because I might have already seen this R cap, and I need to see if this S cap is after it. And then finally, there's the finished expression, which is the, it's just for open-ended. So there's a stack of all of the expressions that I'm in. And it actually, when you end, and you're in open expression, it looks upward through your parents until it finds a non-open one and considers that as something that closes the expression as well. But it doesn't eat it, really. It just leaves it there after it returns, so the next one can close too. All the way up. But it's really easy, since this is all recursive, it just comes down to a bunch of set of rules. It's actually, once you get your head around recursion of this stuff, it makes it hugely easy, because pretty much I'm just consuming stuff, and there's a few rules about how I consume it. It's not so bad. So there's a lot of challenges on the road for this, and I was interspersing with other challenges at work, but I would say the order of operations for infix characters is something I thought the most about, just because I've been so unhappy with my solution to the problem, in that it blocks optimization. Because you can't optimize, you can't figure out infix until you have everything resolved. Because there might be like something in the way. Like something that you're not sure is a number yet, something that, there might be like a whole sub-expression there that turns into some number. You just can't know, so it's really annoying. I mean, you can know in some cases. Yes?
I can help you there, and maybe other people here who have experience in compiler construction.
Oh, that'd be fantastic.
So yeah, I can help you there.
Part of the reason I'm giving this talk today is I'm hoping for a little bit of, if there's anyone around who actually knows, a little bit of guidance around some of these things, especially in optimization. It's fast enough, but it still takes a few seconds to run these queries over like 100,000 records, which is more time than I'd like on a Core i7 laptop. It's not too bad. It's livable, but it's not, everything can always be better. Okay, and then the tuple representation is something I've struggled with quite a bit, because I'm using, this is dynamic, I just use like everything's an object, right? It's all boxed. And that's another thing, is you don't really want to use this language to do lots of math, because it's all boxed, it's not going to be super fast. You can do a little bit of math. Like there's this number of tokens in this name that are greater than this I'm looking for. But I wouldn't use it as like a finance language, certainly not. I mean, it could be made to do that potentially, maybe, but you would require putting the entire numerical representation as part of the expression stream instead of trying to hide everything. And it just makes the execution code a lot more complicated because you have lots more cases to deal with, as opposed to, I'm invoking this, I'm always invoking this. It's very easy. And then the tuple representation is just an array right now. I played with it different things. I tried to make it like, I had this idea recently that everything would be a set, even a set of one thing, and it could make it much more interesting to work in. But I haven't implemented it yet, and it's just an idea, sort of an experimental idea. And then this one-step parsing and destructure thing took me like probably 3 or 4 days of continuous work, just because I kept on coming up with little corner cases where I wasn't doing great. It's hard to think about sometimes when there's so many wheels spinning, but I managed to pin it down. So where we are now is that we have something that can sort of mimic F#. Like this is no problem, right? And I expect this is mostly what Linux will do. But I wanted the power to be able to like type in some stuff that looks sort of like F# in the cases where I was using it and I wanted to run some sort of query. I'm sorry, I should put this higher up on the slide. Maybe I can do something about that. It's gonna be hard. It's small. I'm sorry. It's just so wide. It's difficult to fit in there. One thing to notice about this is that it's like F# except that character returns in white space don't matter at all. So there's a couple of sacrifices along that. So you see, like every let ends with an in, and in bounds it. There's no other way because I wanted everything to be able to fit on the top line, no matter what. Because it's a query language, it's not really supposed to be a full programming language. It's just sort of incidentally that because I wanted to make it that way for my own pleasure, pretty much. So the in is just sort of a expression ending mechanism. It says this is bound in this space. And effectively what this does is it bounds the entire function to this, and then you call it with that. This is a test case, pretty much. So you're saying, so here it's like the build expression of name scores to a Boolean, and then you pass it as text, and then it turns it into a function, and then the result is just by calling that with a record. So the usein is really easy. And there's also a bunch of configuration options if you use there's a class sort of factory for it too. Lets you pass in configuration options. There's also another function representation lets you pass in those same. So you can say things like, so there's one thing that sort of I thought about early on was if you use this in C# and people are using static methods, they're invoking that, they might have some sort of effect on the system. Now I built this with no side effects in mind because that's how I write my code, like even my C#. You know, I know it's crazy, but I find it much easier to maintain. But my assumption is that like you can say let something blank, and then during the first record I go and get that. When you construct it, I'll go out and get that thing and just stick it in my code. So you don't have to call that and do the stupid expensive reflection over and over. But if you were to like expect it to call that every time, then you might be sorely disappointed. But you know. There's an option to turn that off. It just makes it slower because you can't optimize it very much. And then there's another one where you can specify what namespaces are visible from inside of this. Like you can, you know, there's like global namespaces, you can new up objects and other things. So I want to be able to limit that so that if someone is exposing this to clients, you don't have to like reach into the guts of your program in the middle of stuff. Because essentially you're exposing whatever subset of your program's namespace you want to this at runtime to modify willy-nilly. Oh, except there's no, actually that's not true. They're willy-nilly as long as they can be done with a static call or invoking like or newing up something or calling a method that calls something static underneath the hood. Because essentially there's no assignment in this sublanguage. There's no way to assign something over something else in memory. You can bind like something to a name, but you can't actually, and you can bind over that in a subscope. Essentially everything down is a subscope. So you can always write over something else, but you can't ever change something in memory.
It's pure functional.
Yeah, it's pure functional on purpose. But in .NET, so it's not really, like you can still have little leaky cases, which is a little scary, but it's the best I could do. And I would love to add more stuff, like given time, like match and other things. Most recently, I added some set operators because a lot of what we do is we'll have like some set of person names, and you want to call like a function over those person names, and like jar winkler, maybe like a set of pairs of names, and then union them because you have like someone's aliases, and you'll have the spellings of the name. Like with Gaddafi had like 32 different things, like just aliases, or not aliases, just what's it called? Yeah, pseudonyms, but alternate
Transliteration is what it is.
Yeah, and then there's also these pseudonyms. So it's like you have to take those separately, since they come in a database separately, and treat them a little different, and then pull them together. And you want just so that they can query over stuff like that. And the union, there's like this is there an intersection one, which is actually quite interesting in some cases too. So there's quite a bit left to be done. Right now, the generic support is limited. Can't do anything with a generic in it. You can touch things that are fully resolved generics that have everything plugged in, but you can't specify the constant generics. I went to try to implement it, and it was already in production and it's working, and I just didn't want to deal with it yet. It's something that I'd like to add. It's pretty high on the priority list. Error messages aren't great unless you want to read the AST. But it's not really an AST, it's more of a list of things with stuff growing off the list. I see it more like a list of lists, But it doesn't it's not user friendly in the error most of the time. If you hit one of the spots where I find users hit a lot, I'll throw in some error messages for checks in there, like unbounded if if there's a parentheses and no other parentheses or something, or you do a lookup and there's nothing there you found. But in general, I don't know. It's like one of those things that requires a bunch of work, and it's 6 months old, Exceptions are a problem, and I haven't really figured out how to deal with this yet. It's one thing I've thought hard about because they're so slow. Like if you have 100,000 records and you write a bad query and it starts throwing exceptions, the best thing you can do is just bail immediately out of your loop of checking everything, because it can take like 10 minutes if every single one of those 100,000 records throws an exception. Something that would take a few seconds. It's just sort of a part of .NET framework. Their exceptions are ridiculously slow. And you can't avoid them completely. Like, I would have to write my own implementation of every operator and everything else, which someday, maybe. Not yet though. I'm trying to leverage as much as I can. In fact, I really like the generics feature, so I can use the .NET, the F# framework, the core lib stuff, which is not really accessible, it's so generic right now. But the very slow exceptions is man. As of right now, I do some checking inside, and I have a rule about nulls are consuming. So like anything with anything else, with an internal function turns into like null dot something is now null. Null eats that. And null dot null plus something is null. So the idea is that the null will just condense down, so maybe you'll get a null result. And that's usually what happens. So it's been good for avoiding the exceptions. It's a little bit hard to think about at first, but it's a partial solution. And then finally, I really want the match. Like match is one of the best F# features, and I would love to be able to do the cons of the list or something inside there. But I don't think that's too much of a priority, because the users will never ever do that. In fact, they're never going to ever do that. So I've already gone a little bit overboard, but what do you do? The generic stuff would be nice though, because we are using it to write these rules, and sometimes you want to be able to do something that's a little bit complicated. And I'm just like, man, math would be so nice right now, and I don't really want to write it all in this sub-language, or do it in a way that is over objects, because objects are rather painful. So in general, the talk isn't necessarily over. There's lots of code to look at, but I want to throw this up there first. That we have the entire source is available online if you want to get it. And there's going on Twitter and my website. I haven't really posted too much about this. I've been sort of holding off till I felt it was mature enough to talk about and not be terribly embarrassed. Because it's one of those things where it's like you're always worried about that language guy in the audience judging you silently. But very, very friendly language guy we have here, so I'm just worried about that. So anyway, let's look at some of the code from it, the contents and tests. I wanted to give you a conceptual overview before we dug into anything. So in general, the interface is pretty simple, right? You've got a parse and a reduce function, and pretty much all they do is parse and reduce it. Oh, this is not big enough. Huh?
Can I ask a stupid question? You did mention the word AST as a point. The result of your parse is an AST?
It's not really an AST, because I'll show you what it looks like actually. We can go there first. Because I want this part to be interactive about what you guys want to see. So it's this right here. So it's sort of an AST. It can be any of these things.
It's a little bit structures, I guess. F# structures. Total is XML. So I don't know much F#, so that's what I'm here.
Oh well, this is just a algebraic data type standard, and it's recursive. F# has most of the same things. I mean, I looked at the before implementing this, I looked at the mini ML source and as a source of inspiration for
So these are the F-sharp types, the unified.
yes,
That
this
is your
is
AST.
discriminant union with all of these are subtypes of that type.
Yeah, that is your AST, yeah.
Yeah, it's AST, but I don't go as far as like I've seen examples online where people will like maybe this is the secret to the order of operations problem, where people fold up their order of operations AST at when they do the parsing. But I found that I don't have enough information really to do that. So because of the nature of the dynamic.
It's easier.
Okay. So yeah, some of these things aren't used all the time, which is just sort of like, it became sort of like a little bit of a kitchen sink in some ways, which is bad. But also, I've remedied that mostly. There's some things like this resolved and unresolved that, like unresolved can be really bad at the second time through. But I just found if I put everything in here, I'd have to write everything twice. And also, like like some of the things like I don't use really, there's code for it, but I've never put out in the front end like prefix notation. It's supported officially from the middle end back, but that's never got used. This is a sort of, the reflection is the biggest pain in the butt part of this. Like, so method signature ends up being an object array to an object function. So it takes a group of arguments, those are the arguments, and then it produces the result object from that method call. And then there's a tuple with a type array where all the types of those arguments, so you know what you need to pass in. And it's a list of those because there's multiple overloads for any given method. So you have to do your selection based on what types you get, and also their parents. It's actually not much fun.
Interesting. Was there any particular motivation for having the input types paired to the function object as opposed to having the input to the function object be a tuple array where you've got value, object type, as opposed to moving all the types to a single array again?
What do you mean? I don't understand.
Well, in other words, you said the second parameter of the tuple there is the type specifications for the inputs to the function, right? So I'm just wondering, defining them as function and description of inputs to function versus putting the type descriptions in line to the function. In other words, instead of being object array to object, it'd be tuple array of object type to object.
Oh, because it's just easier than the resulting code because you have an array, and then you map that array to the end result, pretty much. It's much easier.
So this is the actual function that you would evaluate, right?
This ends up
That's
like,
the function that we're around.
yeah, it's a
Yeah.
reflection.
You wouldn't be able to call it.
Well, you could use like types would be passed through.
Wait, what? Wait. No, that wouldn't work at all because you couldn't. You need to have the types so you can get your hands on them. Unless you want to put it in the method signature itself and then have like that be cast as an object, and then try to figure out with reflection what the contents of that method.
Oh, I see. You're going to directly invoke that function.
Yeah, this function is like the producer.
Oh, okay. I didn't
Because this
really
actually doesn't
that.
do like straightforward creation of things. It has to do like some pretty fancy caching underneath the hood in order to be fast.
So that's not going to correspond to any .NET function then? Or?
No, it does. It's up here where I generate them. It's the wrong one. It's interrupt. This is the ugliest part of working, guys. So we have like sorry. I don't have everything memorized. It's been about a month since I worked on this project. So let's see, we have something that resolves a single member. Then we have a overloaded member to an expression. So we have all of our parameters that are passed in. Then we map them to the get parameters and array. So it actually produces them. Then for each overload, you have a tuple of the method info and the type. And then I build the function out of that by closing over that and returning them separately. That's nice in a certain way because I already have all the method infos here. And actually, I turned it to be fast enough. The faster stuff is with the, like I do this cache resolve member, because I might not know that. Like this is for the lucky stuff that I know ahead of time from the type, right? Then there's stuff I might not know. Like I need to actually resolve a member. This is if I need to resolve a member later. Let me see. I need to make this bigger probably.
So you can have full overloaded functions and that will resolve which overload at runtime. That's the argument.
Oh yeah, like each of these try resolve is something I came up with for option, which like says if it hasn't been resolved yet, it's a none. Then execute this function to try to figure out what it is or some replacement value for it. So it is, you know, short circuiting. It's sort of like map, but anyway, it's just like I guess it's an anti-map. Right. And anyway, so you know you either get the methods. So the first try, the first try is just get property. Like it might be a property because all I have is a piece of text. I don't know. And then the next try is it might be a method, and I can look and see if maybe it's a method and do some crazy stuff to try to pull it out if there's multiple. Because I have this is the type of the object I'm invoking on. And then it might be a field, and then I try to pull out that field, and then if that doesn't work, then I recurse on all the interfaces and see if that happens. Because the interfaces aren't given to you explicitly when you, you have to get them separately when, like you can get the parents with reflection, everybody included, all at once, but you can't get the interfaces. But the whole thing here is that that's cached using my memorize by. So I provide an input to key function, a resolve member function, and that just is a caching mechanism. And then this is used instead. So anytime this is run, it's only ever done once for a particular type string combination. And then you have to get our types by name, and resolve static stuff, which is a little bit more complicated in some cases. So yeah, it's actually, reflection is a pain in the butt. And this is why I ended up doing it's actually a super pain in the butt, much more so with value types, which is why I ended up casting everything up, just because it makes it easy. Like if you look at my implementation of the parser, so this is like pretty much the description of the whole language. This is the thing that, so yeah, the stuff that happens with the sub-expressions is being kind of complicated. But in general, there's some white space vocabulary that we skip, and there's a special number parser because doubles are in the butt. They just don't fit any of the patterns very well. Not efficiently, at least. And then we have our quote captures. I want to show you this. Sorry, I lost my train of thought there. I got off the tracks. But if you look here, like this divide objects here for the divide operator is just like we're saying it's got infix priority 1, and then it's just an object function. So I mean it's hard to write Barb and Barb, but I don't really feel like that's a necessary feature for this language to have. And then so. Yeah, I want to say in the representation too, is that by default I put in, system, F-sharp collections, and then lib. Even though you can't do most of F-sharp stuff, it's because I've been playing with it, trying to make it work on the side. And this thing, find globals when reducing, is the thing that prevents the optimization, so that you can set false. Also, you can pass in additional binding, which are just string objects, and the object will return. You can say like this is name of this always in your scope in case you have some sort of so in my case I added this because we have a set of tables that we pull from files that we want accessible to the query language while you're running over the records, because you might want to say like, what's the frequency of this name? Or you might want to say like, how likely is this country to be in this data set? So those sorts of things are nice to have in a separate file. I also have a very basic library of stuff, mostly around pulling in TSP files directly, so you can say let blah 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 equals, and then get the tokenized TSP file. And because it only, as long as that variable before is set to true, it'll only do it once, so you can just get the file and pretend like it's being called every time, but it's not. And these are, before, this is sort of my hack around this is why I added operators, because you had these union intersection functions. This idea of pulling in tables off the disk, it's something I added mostly because we need the feature very badly. And so I just was like, no, I don't want to add anything too crazy to language right now. We're already in production with this. Just need like this one. I would like to redo it later so it's a little bit more intuitive, but I think it's reasonable. What else? So yeah, the reduce is actually really fun because it's a bunch of recursive functions that are all co-recursive. There's actually 5 of them. So there's one that applies arguments to lambdas. There's one that resolves a singleton, and as you can see here, it like knows what to do with return to resolve it to the correct type. If it's sub-expression, it knows how to optimize sub-expression. The inside of indexing, it knows how to resolve that. How to deal with tuples and optimize, because a tuple can be a tuple of expressions. So it can. I never needed it. It's probably not necessary. I probably should move it, but whatever. It already does it. This is like the lookup for unknowns inside the map. So I just pass it like an F-sharp map along that has the bound variables and then what they represent. That's pretty much what you stick things into that configuration at the beginning, and you're pretty much just, it's where this is passed in from. So you're saying, this is also in there in the top scope. This generator thing is something I'm playing with. I'm trying to do like sequence expressions in F-sharp, and right now you can do like 1.10 or 1.2.10, like so you can get 1 through 10 or 1, 3, 5, 9, which is nice, but it doesn't really be useful for much yet. Just I would like to someday have all of F-sharp's basic features in some representation of them, and similarly, but it's slow going. And then you have our else, and then for the tuple, there's just like a combination of things, which is interesting, right? So you have a prefix operator and then an object. Well, you have an object and then a postfix operator. It's pretty simple. You just squish stuff together. This is my favorite part to look at because it's so. I find it like the simpleness soothing in a certain way. So you're just mapping pairs to like some parts of the code are rather complex, especially in reflection, but. Whenever I implement anything that fits in this sort of combining stuff set way of thinking about things, it's like it's in and then I'm on, because it's really simple to just combine stuff. I mean, you have an unresolved lambda and then another thing, you just apply it and I collect it up, Is there any questions? Anyone wants to see particular parts?
How do you handle you can have a lambda return a lambda as the result of the higher order functions. We say you have a lambda that returns a lambda, the nested lambda that you return has references to local variables of the enclosing, non-global local variables of the enclosing scope.
So what I do right now is actually, because F-sharp doesn't support recursive definitions of, you can't say like let x equals tuple colon x or something like that. You can't have x inside its own definition, which you can have in ML. So when I tried to, this is actually a big challenge.
So F-sharp doesn't do that?
No, it was a surprise to me, because I was like, this is the solution to all my problems. Lambda was one of those things that took me like a few hours to figure out. It was more than like just to figure out how to write in, but just to like understand enough to to put in. And so I had to do some pretty complicated stuff in order to make it fit. Like I bind it intermittently, and then I put it at the beginning of its own, I shove it into itself as a bound reference. So I clean out all the inappropriate binds. There's a good reason for this. Oh yeah, because it might be being called later, or yeah, this is the problem with some of this. Like I was like, man, I wish I had that mini ML feature. Why doesn't F# support this? But it's really like one of those things that no one ever uses, except when they're building languages. So it's what does it matter, right? So there's this is pretty much just to remove something with a particular same name as the lambda inside of it. So you don't, you're pretty much just unbinding stuff from the global scope inside of it with the same name, and then you shove it inside of itself, and then you have a recursive lambda by. I know this is one of those crazy things that are just like, there's no easy way to implement this, I'm just going to do it the hard way, and thankfully it works well, but you know, we have the lambda here, and then I write the whole thing out, and we have it write it again over here, pretty much to make sure that it's nested inside of itself, so that if you pass it into something else, it's not just when it executes, so it maintains its self-reference. And if it recurses on itself, that recursive version actually has itself bound inside of itself. That's really important so that you can do recursive computation. Because this has right now there's no while structures or anything like that. I had an idea actually for how to do a functional while, because if each iteration of the while loop has the previous iteration in the subscope, then you can overwrite variables that way, and you can have like a while loop that acts like you would expect in a imperative language. I tried it out, but it doesn't feel right. I don't know. But I was thinking that like I got some users that know some basic programming. It'd be nice for them to be able to write stuff. But really, this needs to stay expression oriented in the extreme, so that it can fit on that one line. I mean, that's really the goal. Is anything on that one line that you can put it in. And if you use something that's more complicated, then you can break it up into sublines. This is a terrible carrier term. It's the idea.
Did you think about using just like using F# as a language?
I did, but the hosting story for F# sucks. It's better now, but the whole idea, like if you want FSI in your app, you pretty much have to launch your app inside FSI, and you have to deal with the problems that creates.
What about if you just like, you know, spool up a compiler and make it produce an assembly?
I know they did it with try F#, but there's an issue with separation between your own app domain and the F# app domain and serialization across. So like in Visual Studio, they run it in a separate thread, and so anything that you want to communicate, I tried to write, one of the first things I tried to do in F#, I was like in love with F#, so I was like, I'm going to make a Visual Studio programming plugin for F# and make this way better, and that whole layer was just a nightmare. You know? I know that there are some improvements with the fairly recently released try F# like stuff. I haven't really explored. The other downside of this with F# is that there's still types. Like someone can't compare a double and an integer, which is worse sometimes. I would love dynamic ML language that I can just scoop up. I love ML syntax, but I really need like that. Or some type classes would be nice. I could do type classes. Because you need that correct usage of the operator for the situation. So yeah, it's too bad, but what can you do? I thought of F# immediately. I was like, this would be perfect, and then I was like, this is not so perfect after looking at it a little bit. I did not write this language lightly. I was like, man, for a language. In a way, I was a little excited about it, but I wasn't really looking for an excuse either. You know, tell other depressing things to worry about.
Well, I think this goes back to the sort of the first point you made when you started your presentation. Is that there are general purpose languages, but the problem with general purpose languages is that they have generally a higher degree of complexity, and they demand a higher degree of sophistication in the end user. The whole point of domain-specific languages is tailoring them to domain experts and business users who, by definition, you don't want them to have the same level of knowledge as a developer. Otherwise, you turn your carpenter into a plumber.
Yeah, exactly. Like this is primarily used by like people that investigate, and know some basic. They're pretty good at Excel. They're pretty good at maybe some SQL, a little, but not programming experts. And all of the actual Turing complete stuff that I added was more for myself, and so that when this is in production, I can be like, hey, and solve some problem real quick if I need to, and I'm in the room. And it also sort of leads me into hearing about the questions that they want answered. So if I'm sitting in a meeting with people and they're like, I want to be able to run this kind of query and it's not currently possible, I can try it, see how hard it is, and then be like, man, that sucks. And go back and think about how to put it in the language correctly. It was nice that I can open source the whole thing too, and then if anyone wants to use it, they're welcome to. Talk to some people, but it's fairly niche in terms of the user, like the UI with the query in it. It's not a lot of places where that's necessary in most apps, but any like medium data situation, it works out pretty nicely. There's also, I thought that it would be easier, and it wasn't quite as easy as I thought. I mean, this is probably the culmination of about a month and a half of real work. If I added it all up and taking out all the interspersed, let's say I spent 40 hours a week on this, then it's probably about that much work to get here, which is more than I thought, but less than it could have been, I guess, right?
Do you have client codes, like how this is actually called, maybe in the unit tests project? So we can sort of see how it's actually called.
Well, first I'll show you the library.
So I'm curious how the actual data structures become available to the expression that's being parsed.
So we have build X. This is how I use nyc-fsharp usually. There's build expert with settings and build expert, and they take an input type and an output type. And this one uses the only difference is you pass the settings into. This uses the default settings. And then that's it. That's the API. Now, if you're in C#, I built something a little bit nicer because I do call this from C#. So we have our optional predicate, which ends up not being so convenient in C# because of the way F# handles defaults. It's different than C#, but whatever. It works out fine. It's not too big of a deal. It's like one line in my entire program. Then we have our settings you can set a property for. Or no, you can pass in, not set a property. And then we build our func when you pass it in, and you just call t-execute on over and over by passing it in. That makes it a little bit nicer too because you have to do the invoke on the F# function from inside C#.
But where's the data coming from? I mean, the predicate, I assume, is the expression?
Oh, so the predicate is the function. The predicate is the text that represents the function you want.
Right, where does the data come from? I'm not seeing, it's execute record, where does the record come from?
Oh.
The use cases, I think.
Oh, okay. So let's see. So here's an example of it in basic use from when I started. So we have some sort of F# record. It's do the record with an integer. I know, very creative. But and then we have a parent record. I just want to compare them. This is a particular case where I was testing the ability to reference child objects that are already cast as the object, and cache that. But in any case,
So data.name, name is a property, but what's data?
Data comes from parent with object type.
Oh, I see.
Which is up here and has data.op as an object. So this is a F# record type with two fields or properties: state, which is a string, and data, which is an object.
Right, so now when a user's actually working with the predicate, do they need to know the actual name, or is it one of those things where the actual type of the record, the structure of the record is basically, what's it?
So when you when you name something here, right, you're saying build expert with something to something.
Mm-hmm.
I know what the structure of that first thing is, so I built that out ahead of time. So I call that thing that generates the functions. So I know the name, so at least I can generate all of the possibilities, right? And then I shove them into that data structure, and then a special data structure that replaces stuff as it goes along.
I guess you're not giving your end users, FSI or an script file as their interface. They've got a proper, you're giving them a proper UI that they're typing it into, obviously. So.
Yeah, it's just a text box. I like that.
But the point is, there's a layer of, you're not expecting them to do the execution. There's some mechanism. You're hiding the execution behind a text box and button.
Oh yeah, definitely. They just type it in, hit enter, and then it filters the records appropriately. It's not like the user specifies different kinds of records. I mean, I have a, it's all WinForms, like the app that I built, because I know WinForms at the back of my hand. I've been doing it for years. I never really bothered with WPF because it's not very F-sharp friendly. And it's just a list, and the list with all the record things in it, and you just type the thing in, and it shortens the list, and then it's all generic. So the T of whatever the list containing thing is that calls this knows the type ahead of time, and I just kind of put it in. I mean, I could show you some of our, I could show you our app that we use this in if you want, but I can't show you the code really, unfortunately. I mean, it was pretty interesting. I mean, we have our.
But I mean, the point though, your unit test where you're building the expression from the string and then invoking it against a particular record or set of records, that build and invocation is hidden behind your actual application. And the end user doesn't see all that. The end user can see it. The end user is just typing in a string and hitting a button.
No, there's a property on whatever the thing is called that you use for data finding when you do search. So it builds it in, the ability to do filtering. I think it's .filter is the name of the property, and it's just a text string. And then so when it's set, if it's changed when it's set, I compile it up and then run it over the records. And then I keep two sets of records around all of them in the set that you're looking at. It's pretty simple stuff in general, but it works. It works really well. But yeah, there's a lot of different tests that had to go into this. Like there's over 100 tests, mostly because I wanted to be sure that when it was in production, it didn't explode. And worked in all cases. My favorite were the recursive ones, just for fun. Oh yeah, and the new stuff. You can do newing up stuff without actually doing the new, so that someday I can actually do the expression types correctly, or the string use correctly, but it's not all the way there. All right. Well, I think that's about it, right? Like, did anyone? I mean, I could show you it in action. I guess let's do that real quick. I'll just pop it up. I have some public data I can use with it, and that's.
It's been sanitized properly.
Just the FAA piles license list that we use to test on. So it's not real bank data. So this is the app. All settings. Right, plugged in. Okay, so there are FAA records. And it just takes a while. It's a bunch of processing over them. Probably takes like a minute. But what it's doing right now is it's like figuring out gate formats and other stuff based on frequency inside, and then does a bunch of they have like a pre-learned naive-based model that we use to score how risky, or not risky really, but how likely someone is to be someone else on the list of politically exposed persons, which are like presidents and war criminals, pretty much, members of Congress. So this is all the stuff that spits out a log normally. And then we just want to look at the record view. And we have all the records listed here, the stuff at the top. You know, pretty much like this is all tons of debugging information about it, back-end storage information. It's not supposed to be a use. This is more of like we got a new data set we're looking at. There's a console version of this too. This is for like someone tweaking all the settings up before it goes into production, pretty much. We also use them to actually define some of these machine learning tools on this. And then we would go custom dot contains. Everything is always harder.
What, no IntelliSense?
It's coming in 2.0. And then it runs it over the records and just looks for that, and we have the records that contain that. It's easier subset. And it's just an easier way for someone to cut the data up. It also affects other views on the data, so you can look at like properties of the data based on some subset. So usually we want to find, there's certain corner cases in the data that are really important. Like, and there are properties that vary from customer to customer. Like, sometimes it's really important that we look for, let's say you have a bank in Washington. It's going to have a much different customer profile. Washington, D.C. is a much different customer profile than a bank in Kansas. A lot more people we care about, so we'll be able to adjust a bunch of stuff and look at cut of the data and understand it better. But yeah, that's pretty much where Barb lives. And it lives in the settings file too, and the ultimate stuff. But it's been very successful, and I'm pretty happy with it. So if anyone actually does try it in some sort of context, I hope you'll let me know. Also, I do take patches if they're good. Well, thanks for coming. It was only about an hour, but yeah, and don't forget I just want to say one more time in case anyone came late. The progressive F-sharp tutorials are coming to New York City, and they're going to be awesome. Don Stein will be there. Phil Trulford will be there. Tomas Petchek will be there. I'll be there. Chris Marinos will be there. It's going to be, Kevin Hazard will be there. Just locking down the schedule now. So things are really moving forward. We've already got the venue, everything's set up, it's happening. It's going to be super awesome. If you love F-sharp, be there. I'll get into that off camera.